fellow introverts. This is Stacy, your programming and test automation expert. Today we're talking about Python decorators. This is the second video about Python decorators, so if you haven't seen the first one, please check it out on our channel. But today we're going to move forward and we're going to talk about applying decorators to classes, as well as we're going to take a look at the most common cases of using decorators for classes that handle APIs. Also, we're going to do some advanced trickery today, so bear with me. Brace yourselves. But we're going to do it in a second. I will try to explain it as much as I can, and we will also discuss whether you should do such things or not. So without any further ado, so let's get on with it. Okay, so first of all, let me show you which code we already have. So we have a class that represents an API. Let's assume that we only have a post method here right now, and we handle some data which is sent with the request. We update this data, we just add a timestamp to this data. Well, of course, naturally in an API you're going to save it to database, you're going to do something else with it, but for our case, just to be simple as we can, we are just adding a timestamp here. And we then return the updated data. Here is the creation of the object, and we also do this post request. So let's run it and see if it works. Okay, so we have the result. As you can see, we have this timestamp, and the result type is a dictionary. So first thing that we would like to do is actually we assume that our API always returns JSONs. It receives JSONs and it returns JSONs. So we could actually verify whether the incoming data is a dictionary. This is something we did in a previous video. And now we want to actually operate on the return type of the decorator, and we want to automatically parse it into a JSON. This is how most of the servers work. You have to make the data a JSON before sending it back. So most of the Python server implementations do it automatically, or you have to apply actually a written decorator, the one that already exists in that library. But we're going to go ahead and implement our own. So let's do that. I will call it, let's say, JSON response, assuming that we can have an XML response or something else. And we're going to put func here. We're going to have our wrapper with args and quarks, okay. And we want to call our function here, so we will do something like result func args quarks. And we want to return the result for it to work, and then we will return the wrapper. Okay, so now what we want to do, we have our function call here, and we want to actually make this result, which is going to be our updated data, we want to make this result a JSON. So let's go ahead and do that. So we will do import JSON, and we will do JSON dump result. So the decorator is ready, we can apply it. JSON response like this, and let's run it and see if it works. Okay, as you can see, the data is still being outputted, but we have another type of our return data. So now it's a string, which is actually what we want, because JSON is a string when you dump it. Okay, so this is the first case. This is a very good thing to do, so I really advise it. This is a very good thing to do with decorators. And something else that I wanted to show you what you can do is actually, let's imagine that each request want to have a unique ID, because we want to be able to trace it somewhere in the logs. Maybe you use New Relic or something else, and you want each request to have a unique ID. Usually you would do it in headers, but we will do it in data. Doesn't matter for our case. So let's create a decorator for that. let's create a decorator which would be called, let's say, with request ID func. We can copy this guy. Okay, and we want to remove this one because it's being done in JSON response. And now we would need to create some unique ID. So let's import UUID module. And let's create a variable rec UUID, let's say UUID4, and then the result is our data, so we can just apply, add this information about the unique ID to our result. So we will do result update a dictionary rec ID and our value. Okay. And then we return result, we return the wrapper, so should be fine. So let's do this. Okay. So naturally you would think that we would do something like this, because we don't want our response to be parsed before we update our dictionary, which is returned with the method call. So let's try to run it. And oh, we have an error. So actually in Python it works vice versa. So the closer to the method, the earlier the decorator is being called. So in our case, to fix this error, let me show you the whole error. So as you can see, we were trying to update the string. So this JSON response decorator was already called and our data is already a string. So this is not something that we want naturally. So we have to actually change the order of the decorators like this. And let's try to run it now. Okay. Yeah, we have another error, but this is related to our UUID because UUID is an object of UUID and we want actually to have a string. So we would need to do something like this, hex. Okay, so now as you can see it works. Let me show it to you again. So we see a string here, so we could actually change the order back. This wouldn't work because JSON response is closer to post declaration, so it will be called first and then we will call the with request ID. So we have to put them back like this. Then with request ID is closer to post method and it will be called first and then we will call the JSON response. Yeah, so like that. This is something you should bear in mind when working with decorators because the order makes sense. And it's not like alphabetic order, but it's the closer to the method you are, the earlier you will expect this decorator to be called. Okay, so now bear with me because we are going to complicate things very much. So let's imagine, I will just go ahead and remove this with request ID because we want some space here. Let's imagine that we assume that our API always, for all of the HTTP methods, it returns a JSON. So we don't want to copy this decorator for each and every HTTP method. We just know that there is going to be a post, get, like the basic ones. And we want to always parse their return value to a JSON. So naturally, what you would think we might do, we can apply this decorator to a class like this, and then whatever you have here, you have post, you have get, you have delete, anything else. If it returns data, then it's going to be parsed into a JSON. So let's go ahead and try to implement something like this. It's going to be complicated, so brace yourselves. So first of all, we have our decorator, but it's going to receive not a function, but a class here. So first thing I would do is actually to change the name. just to be sure that we know that this is a class. I will remove these guys for now, and we will start from scratch because it's going to look a bit differently. So what happens if you apply a decorator to a class? Let's first of all try to print it and see what happens. Print, as you might presume, we're going to have class and args quarks. And let's probably just do it like this, result, okay, and result, and we will return result. So kind of like with functions or methods, but we're doing it on a class right now. So what is going to happen? I will put a breakpoint here, and we will do some debugging because it's going to be a bit, well, it's going to be expected, but let's see how it works. And I will go in. I'm going to put a breakpoint here as well. So let's run a debug and see what happens. So now we're at the point that we're creating our object. So let's go further. And tada, we're in our decorator. So let's see what is a class. A class is actually our API class. So this one. And let's go further. So we actually created an object, and this object is actually the object that we create here. So this is this API lowercase object which we're creating here. Okay, so if we print it, we're going to see the same thing as we can see in the evaluate expression, and we can go further and just run it further. Okay, so now, what we're going to do? First of all, we need to specify which are the HTTP methods that we're going to use in this case. I will just collect the most common ones, so let's call them HTTP methods, method names maybe, like this. And we're going to create a tuple, and we're going to have post, put, get, delete. You know, there might be some other ones, but we want these ones for now. So, okay, so we have like our collection of methods. Now, what we need to do, we have to actually determine whether the class has such a method. And if it has such a method, then we have to get it somehow and somehow modify its return value. So this is going to be very dynamic. But first of all, let's start with trying to find whether a class has such a method. So I will go ahead and rename this result to created object. We're going to remove this print for now. And to understand whether a class has a method or not, we are using a built-in hasUtter function from Python. And we want to actually go through these methods, method names, and we want to check whether the class has them or not. So let's do it this way. For HTTP method name in HTTP method names, we're going to do if hasUtter, like this, and we're using our created object, and we need to pass the name here. So we're going to do HTTP method name. So if it exists, then we want to actually get this method reference. So to do that, we're going to use get attribute. So the same as hasUtter, we're going to use a getUtter. So we will do method reference equals getUtter created object, because we're getting it from a created object, and we take our method name, HTTP method name. Okay, so now we have a reference to our method if it exists. So if, let's say, if post exists, and it does, then this would be executed. We will get a reference to post. We're not going to call it, but we're going to get a reference to post. Now, what we need to do, we have to update this method on our instance, on our object, to when it's being called, then it's going to return not a dictionary, but it's going to return a JSON. So here we're going to use the third function from Python, which is called setUtter. So let's go ahead and do this. setUtter. What setUtter receives as parameters? So first of all, our created object, because we have to somehow find the method on the object. Then you've guessed it, we're going to do HTTP method name. And here, as the third parameter, we actually specify the new value of this attribute. So to do that, we actually need to somehow modify the method name, but we don't want to call it right away. So this is going to be a bit JavaScript style thing, but we're going to create a lambda function which will receive our data. So when the method is called, then the data goes into the lambda function, and then we actually parse the data, and we call our method, we parse the data, and we return it as a JSON. So bear with me, let's write it out, and it's going to be more clear. So let's do a lambda data, and we need to call our method. So we will do method ref from data. So we need the lambda again because we want to create a function that will be called later. So we don't want to call it right away. And still, we want to call our method once the lambda is being called. So this is why this construction has to be done. You can, of course, write it as regular functions, but we can use lambda here because we don't need a named function for this. Okay, and what we would need to do is just to do a JSON dumps here. So we would do JSON dumps on our data. And this looks to be it, to be honest. Let's try it out. I might have made some mistakes. It's already applied, so we can actually try to run it. Okay, so we have result not defined. Let's take a look where it happens. Sorry, I've renamed it here, but didn't rename it right here. Okay, let's try it out. I really hope it will work. And ta-da! It actually works. To show you whether what is the benefit of this approach, we can create another method here. Let's say put. And we will add data here. Let's do another update so it's more visible. So we will do update. We will do data update. I don't know. Blah blah. Blah blah blah. Okay. And we will just go ahead and return the data. And as you can see, we don't have any decorators applied to these methods. Everything is being done here in our API class. So let's run it. We have to actually call the put as well. So let's do result1 API put name pop1. And we want to do the same thing with the result1. Result1. 1. Okay, let's run it. And as you can see, it works. So let's probably summarize it again, because it was quite complicated while we were writing it. So what actually happens here? You apply a decorator to the whole class. What we do next is when the instance of the class is being created, we do it here. Then the decorator is being called. We receive the class reference here, and we receive the arguments and keyword arguments, which we would have passed to an init method if it was there in the class, but we don't have it actually, but it doesn't matter. So we create our object here. It's going to be returned here, and it's going to be written to this variable, to the API variable, and we're going to operate on the same object later. But what happens inside of the decorator? We have the object, we have our HTTP method names. We go through all of the HTTP method names and we check whether this class object has any of them. We go one by one, and if this method exists, let's say post exists on a created object, then we get the reference of that method. We don't call it, we just get the reference to be called later. And we override this this method so that we make it a lambda. So basically it's not called right away, but this lambda ensures that we're going to do a JSON dumps when we call this whole lambda. It's going to do a JSON dumps and call our method, and we're going to receive the result in JSON. Okay, so this was quite complicated, but we succeeded, yay! So should you do this in a project? I would be very, very cautious with such things. Sometimes you might want such things to be done because it makes your life easier, but you have to be absolutely sure that all of the things that this class will contain are going to return the same type of data. So this actually gives you some kind of a restriction, which is kind of good because nobody will return a string here, because otherwise the decorator will fail because it will not be able to do a JSON dumps. So this is kind of very good. What I would advise, if you take such approach, then you would need to actually do a good exception handling and have good human readable messages for these exceptions, because otherwise it's going to be hard to understand what is happening here. But I would say something like this. So be cautious. In general, the approach is okay, but I would be very cautious here because, well, this stuff is not very easy to be read. And I would keep this stuff in a separate module so that it's some generic things. They're not kept with other things. So these are sort of parsers or something like this, so that only the people who want to make changes in them, they would go there and do changes with them. Because if you keep it in somewhere in between of your APIs, then somebody, when something doesn't work, they might go to this decorator and try to update it so that their thing would work without actually understanding what is happening inside. So this is a bit tricky. So be careful with such things. So, okay, I guess this is it. I'm very proud of you if you are still looking at this video and understanding what is happening. So kudos to you. I hope that you liked the video, and I will see you in 1 week with a new topic. We finished with decorators. And subscribe, like our videos, and I will see you in a week. Have a happy coding and see you next time.